Anyways, today's the 24th. And what we are doing today is, yes, quadratic formula. But again, other than me singing it to you a minute ago and reciting it really fast, we're not going to really specifically talk about the formula itself. What we're doing are quadratic formula, just the endings. You'll find this to be beneficial. And when tomorrow comes, you'll go, so that's what we did assignment number 54. Got it. So the endings, when you do the quadratic formula, and part of me really wants to write the formula up here on the board, but I'm not. I'm going to just show you this is what your answers are going to look like. So when you finish a quadratic formula problem, you're going to get something like this. X equals -6 plus or minus the square root of 8 divided by 10. And that looks completely weird today. I get it. But this is what the ending of the quadratic formula looks like. And so after you've put in all your B and A and C values and done all the math, it condenses to look like this. And the question becomes, like, how do I simplify this answer? And, there's a couple different roads we can take. When we do application problems, we'll put it in our calculator and we'll get decimals. But we're not after that right now. What we're after is just pure simplified perfection. So you ready? Here it goes. Step one is to use the skills that we acquired yesterday. And quite specifically, the first thing we're going to do is we're going to go tackle this. And so again, my question is asked with the assumption that you know how to do this. So off to the side, we're going to go take the square root of 8 and we're going to tree it down into two blank square roots. And what numbers are we going to use? 14. Yes, and we're going to use them in that order. We're going to use 4 and 2. I've kind of got the reverse color scheme going on here today, but I want that 4 to stand out because what's the square root of 4? It is 2. So what we're going to do is we're going to take that red circled thing and we're going to swap it out. And our new answer is going to say -6 plus or minus 2 square roots of 2 divided by 10. Do you have any questions yet? Okay, the next thing is what I have come to know as the Dorito. The Dorito of awesomeness, you can call it if you like, but you're going to see why I call it a Dorito in a second. What I'm going to do, and of course the Dorito is completely optional. I just, as a teacher, try to come up with stupid things that will help kids to remember what to do. So I draw this guacamole colored Dorito, and I want you to notice that my Dorito does not include the square root. He doesn't get to play in the Dorito, okay? So only the number that's before the plus or minus sign, and then the number that's attached to the root, and the number on the bottom of the fraction. And the reason I want you to consider the Dorito is because the question is this: can every number in the Dorito be reduced? What can they all be divided by? So that's going to be our next step. Usually the final step. We're almost there. So we're going to take every number in the Dorito and we're going to divide them all by 2. So this is going to become -3. What does this 2 become? 1. And this 10 becomes 5. So the final answer to this problem, if this were in your assignment, would be x equals -3 plus or minus √2 over 5. And the question that you would have been more inclined probably to ask in September or October than you are at the end of April is, where did the 1 go? And I think you know the answer is that you know in math that we don't put 1s when they're multiplied by things. Like we should not still be saying that like 4x minus 3x is 1x, right? We just call it x. So if you want to put the 1 there, it's not wrong, but it's generally good to just leave it out. Believe it or not, that's what the final answer is going to look like. We simplified the root, we hit it with the Dorito, and we moved on. Got it? Yeah. Okay, now I'm going to shoot a bunch more examples at you. So here we go. The next one, and I'm going to stop writing x equals. I'm just going to give you the meat and potatoes part of it. So we're going to have 4 plus or minus the square root of 27 all over 6. What's step 1?
You have to
Yep, simplify your root. Get used to saying that. Simplify your root. So I'm going to go off to the side with the square root of 27, and I'm going to tree it down. Yes. And I'm going to put the 9 in the first square root because it's the good one. And I'm going to put the trash leftover in the second one. And what's the square root of 9? So we would say root 27 can be expressed as 3 root 3. So the next thing I'm going to do is I'm going to rewrite my answer as 4 plus or minus 3 root 3 over 6. And drawing the Dorito, I just want to reiterate this so I don't get any parent phone calls about like, what are you teaching my kid to do here? It's of course, again, optional. It's merely a visual aid, a teaching tactic to get you to really focus on those numbers. So lock them in, whether you draw it or not. What can every number in the Dorito be divided by? You can't. Good. And so for that reason, it's already done. This would be our final answer. I'm going to throw a lot of examples at you during the lecture. And the reason is because there's different things that can happen. And we just encountered one of them. Well, two of them. The first one, we broke down the root, and then the Dorito was successful and we moved on. This one, we broke down the root, but the Dorito was a non-issue, so we just stopped.
What if you get, well, this might sound stupid, but
No, no,
what
no.
if you get like, so it's 9 and 3, what if you get two good numbers?
Two good numbers.
Like,
You mean like if I had the square root of 36 and I did the square root of 4 and the square root of 9? My answer is that you shouldn't have been making a tree in the first place. If you ever get two good numbers, it just means that the square root could have been taken in the first place. Does that make sense?
Yeah.
Yeah, if you ever get two good numbers, like if you're looking and you get like a 4 and a 16, you should give yourself a swift kick in the butt, erase it, and then go, no, I should have just put 8. Yeah. With me?
Yeah.
Okay, good. All right, let's keep going. Next one, negative 10 plus or minus the square root of 112 divided by 12. You might remember 112 because I think it made it into the lecture notes yesterday.
Yeah.
So what happens is you build a database of roots and you start to see them and you're like, 147. I remember you. 180. I know you're 36 and 5. I know this guy. He's 16 times 7, right? You start to have familiarity with certain numbers when you see them again and again.
16.
Right. So we're going to take that square root of 112 and we're going to tree it down into the square root of 16 and the square root of 7. And what's the square root of 16? So this is 4 root 7. And again, what we're going to do now is we're going to swap it out with the old and with the new. So it's negative 10 plus or minus 4 root 7, all divided by 12. And Dorito, guacamole, Dorito comes in, and I'll stop drawing the Dorito probably eventually. I really want to lock you into those numbers. What can they all be divided by? Good. And if you divide them all by 2, then it's ready to write the final answer. So here we go. What's the first number going to become? Plus or minus what? 2 roots of 7, all divided by. All right, guys, good. All right, let's keep going. This one's going to freak you out a little bit. In fact, I'm going to call an audible and I'm going to do the next 2 problems out of order because my puny little brain just told me that I should. So here comes your next one. I'm switching up the order. I want you to write this down right now in your notes. Are you all taking notes? I want you to draw an arrow to this, and I want you to call this a pathway problem. You'll see what I mean. First things first, what do we do? Yeah, what are we going to do with that 16? Cal, should we break it down into like 4 and 4? Should we make a tree? No. Right? It's just literally 4, right? So this is going to be a pathway problem because this square root is actually already on your list. Like it doesn't need a tree, right? The square root of 16 is 4. Like not root 4, just like second grade 4, the 4 you learned a long time ago. So what my answer is going to look like now is 12 plus or minus 4 over 8. This is where I've decided over the years to start calling these pathway problems. And what I mean by pathway is that we're not going to stop. The rule in math is you do math until you can't find any more math to do. That's what the word simplify means. And I can do math. I couldn't have gone further with that. I can't combine -5 and 2 root 7 because they're not like quote unquote like terms. But I can take the pathways, and I'm going to show you what pathway number one is. Pathway number one is called plus. A plus or minus is literally a set of like two instructions. And so we're going to actually divvy this one up into two separated answers. Follow the plus pathway and ignore the minus. And on the top, what is 12 plus 4? So one of your answers is 16 over 8. And what does that equal? 2. Now we're going to trace the other pathway. And again, we're only doing these pathways because, well, we can. And the other pathway is called minus. What is 12 minus 4? So the other answer is 8 over 8, which is also known as 1. So your answers in this case are not going to look like they normally do. Your answers in a case like this are 2 and 1, two separate entities. So that's called a pathway problem. It's not really called that. I just call it that. You don't have to call it that. What's funny is the next one I'm going to give you is the easiest one, but I think it's the one that has the most potential to just quite frankly freak you out. So here it goes. As I sat here and I tried to write the notes for today, I was thinking of all the things that can happen when you are working the quadratic formula. And this does happen. You're doing your b squared minus 4ac inside the root sign, and suddenly you realize, oh, snaps, it became a 0. So we'll follow the same steps. What's the square root of 0?
0.
Okay, so it's going to say 9 plus or minus 0 over 2. Let's pathway this sucker. Nash is looking at me like he's looking at my board like, what's this man talking about? Let's take the plus pathway. What's 9 plus 0?
9.
9. So one of the answers is 9 over 2. Let's take the minus pathway. What's 9 minus 0? 9. What's 9 over 2? Well, it's 9 over 2. Problems like this only have one answer. I mean, really, you'd have to agree. In theory, that should be the easiest thing anyone asks you to do all day. But it causes a lot of stress just because we think there's got to be some more meat on the bone. But the fact of the matter is, if there's a 0, it's just one answer. Because adding and subtracting 0 is pointless, eh? How about this one? Eight and what?
9. 8. Just
Good. I'm just picking on Cal because I just want to make sure we're good based on his question. So yeah. So again, don't fall for this. Remember, I'm giving you a softball here. The square root of 64 is like a number 8. So our answers are 5 plus or minus 8 divided by 2. And what do we do?
add 5 and 8.
And correct. So it's this, we're going to trace the pathways. It's like a choose your own adventure book. Like, so we're going to take the top pathway first. What's 5 plus 8? And 13 over 2 is quite literally 13 over 2. That's one of my answers. And then I'm going to shift back to the beginning and I'm going to take the other pathway. What's 5 minus 8? It's not 3. It's -3. So the other answer is -3 over 2. So you see how we're getting like normal answers sometimes, but the rooty, those are called rational or irrational. These are rational numbers. The other ones are irrational numbers. Okay, I got a whopper for you. Do you remember a trick that I explained, I showed you yesterday as to a good strategy when someone gives you a really big number and asks you to square root it? Try dividing it by little baby trash numbers. Do you remember that expression, baby trash? Like the first baby trash number that you should ever think of is 2. 2 is a worthless pile of dirt. But dividing by 2 or 3 or 5 or 6 worthless numbers, the division problem often produces good results. So probably don't need a calculator for 648 divided by 2, but I won't judge. If you divide 648 by 2, what do you get? Are you interested in 324? You should be. The square root of 648 can break into the square root of 324 times the square root of 2. Why are we interested in the square root of 324? Because it is simply put 18. That's on the list. Right? So just because you got big numbers doesn't mean you're scared. Don't be a little chicken. Divide by 2, 3, 5, 6, 7, 10, 11. Numbers that are worthless in their own right. They'll often produce results. So I'm going to rewrite my answer now as -9 plus or minus 18 roots of 2 divided by 18. Drawing my little triangle this time. Can all the numbers in the triangle be simultaneously reduced? 9. Every one of those numbers can be divided by 9. So if you divide them all by 9, what do they become? -1. You do need that one, by the way. Some ones can go away. Not that guy. He's a placeholder. -1 plus or minus 2 root 2 divided by dope. How about this little fella? Love it. 25 is a great number. I always ask myself, can I make that money using quarters? $1.50. Can you make a $1.50 with just quarters?
Yeah.
How many quarters?
6.
So you don't need a table or a calculator to tell you if you got 6 quarters jingle jangling in your pocket, you got a $1.50, right? So I can take my 150 and I can tree it down into the root of a 25-cent piece times, well, 6 of them like that. 6 quarters makes a $1.50. And what is the square root of 25? So we have 5 root 6. So I'm going to take now and write 15 plus or minus 5 root 6 all over 20. Does the Dorito make progress? What can every number in the Dorito be divided by? 5. So you're going to just take all the numbers. Look at me not drawing the Dorito. It's a big step for me. Divide all these numbers by 5. Boom, boom, boom. What do they become? 3, 1, 4. And the 1 doesn't need to be there. So like I just put it there, but in my final answer, I'm going to choose not to write it. So my final answer will be 3 plus or minus root 6 all over 4. Okay, if you ever get to a point where just these two numbers in this little like Frito shaped chip can be divided, don't do it because they've got to be part of that 3, that triangle. It's got to be like everyone in the group has to agree to the division. Okay. I I feel like I've just about nailed it here. I had one more that I really, yep, it's this one. Uh, this is my final example. 9 and 8 is not a terrible answer, but it is not what I want. And yeah, and I'll tell you what, the number 8 causes a lot of headaches in algebra because it's a part of a lot of cool multiplication problems. Um, but eight's no good because it could still be broken again, right? So if you ever leave a root as an 8, make a note to yourself, bad guy, bad guy, bad guy. That means that you didn't dig deep enough, right? So what we want to do is take that 72 and remember the old baby trash theory is divide by numbers that are worthless. 2. 2 is a pile of dung. But I do like what happens when I divide by 2. 72 divided by 2 is 36. And that is interesting. What's the square root of 36? So what we're going to do now is we're going to take the square root of 72 and we're going to substitute it out. And in its place is going to come new and improved homie. This guy, he's going to be like, whoop, look at me. I'm the new and improved root 72. Fill me in. Put me in, coach. Divide everything in the Dorito by 2. So what are we going to get? 1 plus or minus 3 roots of 2 over 2. Everybody feel like you got this?
Yeah.
So today is dedicated to just dealing with this skill so that tomorrow, when we get to the end of the quadratic formula, we don't have to go and relearn all the Dorito stuff. Like you're going to be, tomorrow can be dedicated to the formula because we'll already know how to do the endings. So, all right, I'll pause this and I'm going to hand out your worksheet. And if you have questions, let me know. Anyone's interested, come along for the ride. Problem number 5.
That's the 75. That's 75. Yeah, so you just leave it there.
I'm going to pause my Spotify queue real quick
No, space by space.
so I can. Okay, so you know this. You should know this because this isn't an understand it or don't I understand it thing. This is a what do we do first? What do we do first? Okay, so then part of it is that you just need to write down the steps. So step 1 is always to take this square root and do what you did on last night's homework. So we're going to go off to the side and we're going to just redo this process that you mastered yesterday. So we always draw it and then we draw 2 branches and then we at the bottom of each branch we draw 2 empty square root signs multiplied by each other. Good. Now what do we multiply to make 75? That is the only acceptable answer. There's another way, 15 times 5, but those are, of course, no good. So I appreciate you. Good job. So what we're going to do is we're going to put 25 here and 3 here. And the reason I wrote 25 in red is because, like we learned yesterday, 25 is on our sheet, that cheat sheet I gave you. What is the square root of 25? So the answer is 5 root 3. Now, what we're going to do, and I don't want you to do this. I don't ever want you to erase things, but like I'm going to take that out and put this in. Bless you. Do you see how that works? Are you with me? Hey, you good? You sure? Okay. Now, once we survive that step, what we're going to do is we're going to, until you don't need it anymore, you're going to draw this little Dorito, this little triangle, call it whatever you'd like. And you're going to ask yourself this question. What can every number in that triangle be divided by? Nothing. So what do? We leave it and we say, well, I guess this problem's over. You put a box around it and you say, that is my final answer. Sometimes, and we saw one of those, at least one of those in the lecture where you simplify the root only to realize that it won't yield any further results. Does that answer your question? Did you get that far and just didn't know what to do or what? Yeah, sometimes you just get what you get and you don't throw a fit. You just move on. You want to do another one? Like what? I'm going to pause the recording while I ask you a very simple question. So again, I'll tell you the same thing or ask you the same question. Did you get yesterday's homework done?
I mean, I tried to get it.
Just a yes or no question.
I didn't get it.
That's just a yes or no question. Just no? Okay. So that's going to be largely what causes us to struggle. And that may not be the only issue here. Like it could be something after that. But where we want to be today is we want to be able to break this down 100% of the time. So you with me over there, Jackson? We're doing number 1 if you're interested. So we're going to go off to the side. How are we going to break this down?
I'm gonna say we could try 220.
Sure. Yeah, and I can try both of the things you guys said, and then I'm going to quickly discount them both. What is the square root of 2?
Nothing.
It's nothing good. What's the square root of 20?
No.
It's nothing good. And if you're staring at me wondering, why do I know that? It's because it's literally on that piece of paper that you had. Like, the square root of 2 is not happening, right? So we don't want to pick 2 and 20. I've got no issues with the fact that 2 times 20 equals 40, but why use those? And I'll say the same thing about 8 and 5. 8, listen, I'm happy that you know that 8 and 5 make 40, like for real. But again, what's the square root of 8?
Nothing.
Ain't happening. Square root of 5 ain't happening. So what we do is we search through factor pairs until we find one where the answer to the question is not nothing. There is one pair of numbers that multiplies to make 40. And what is it?
4 and 10.
It's 4 and 10. That's the only pair you could possibly want in this scenario, because if I write 4 and 10, this time the answer to my question isn't nothing. What's the square root of 4?
2.
So the root simplifies into 2 root 10. Got it? So what I'm going to do now is I'm going to take the old square root of 40 and I'm going to pull it out. And where it used to be, I'm going to put the new and improved version of the square root of 40. Not yet. Yeah.
Wait, Mr.
Yes, they can. So what we're going to do, and remember, when we talk about this, you are not looking at the root, right? He's not in the Dorito. Good. But those other 3 numbers that out in the open numbers can all be divided by 2. So like this one becomes -7. This one becomes 1, and this one becomes 3. So now what we need to do is write the actual final answer. What's it going to look like?
-7 sine
Plus or minus,
+/- 1 root 10
and I'm not going to put ones where they don't need to be. You can though, honestly, it's fine.
divided by 3.
That's it.
No, you can't do that.
So if you actually go back and finish last night's homework, you will find today's assignment to be 76,000 times easier.
I really do understand it.
Give it a shot. Okay, you try.
I'm just talking.
If I were you, I would go to that sheet that I gave you yesterday, and I would, yeah, remember the cheat sheet that had all the square roots on the top? I would flip it over and I would start writing down ones that give me problems. And what I mean by that is, like, someone's asking me right now about the square root of 48. And man, if I had $1 for every time someone messed this up, I could probably pay off like a third of my house. Like, it's crazy. But what happens is if I just know it and I write it down, then it never defeats me again. What is the money jackpot combination for 48? It is 16 times 3. And what we want to avoid is exactly that. We want to avoid 4 times 12 because 12 still has meat on the bone. The money combo for 48 is 16 and 3, which becomes 4 root 3. Every time you see a new one that you feel like it kind of maybe got the better of you, go to that cheat sheet, flip it over, and add to your resources. And then when you have that sheet out and you encounter a death number like 48 or 80 or 96 or the harder ones, then you flip it over and you're like, boom, I got it on my cheat sheet. So that's my advice to you.